So, welcome to Set Theory 6, I believe. And we are working on the final section in the textbook, which is section 2.5. And it's really about survey problems and how you can take surveys and do some set diagrams with them. And so there are a couple of things that happen. You've seen this diagram that I have here with regions 1, 2, 3, and 4 in a two-set example. And the difference happens when they ask certain kinds of questions. Now, for instance, if I were to ask you how many elements were in set A, right? So in other words, I'm asking you the number of elements in set A. And in fact, in this particular problem in your book, the number of elements in each region are listed in these circled numbers. And so to find the number of elements in set A, I would actually add the number of elements in these two areas, this area and this area, and by adding those two numbers I get 17 plus 9, or 26 elements in the set A. And so what's happening is now they're asking the questions in terms of cardinality. One more example for this two-element set is this one. They say, how many elements belong to neither set A nor set B? So that's the number of elements in neither set A nor or neither set B. And so that is the number of elements in A complement union B complement. And so that's a little different phraseology than we've seen before. And so we have to take A complement, which is going to be these elements right here, 11 and 7, so that'll be 18. And then B complement, which will be these elements right here. And what we see is there are 24 there. However, we've counted this 7 twice, so we need to pay attention to that issue and make sure we only count the 17, then the 7, and we don't want to count that twice, so then we put the 11, and so we add those three together, and we end up with 24 plus 11, or 35 elements. Okay? So I'm going to show you one more example that's a little trickier, and you can kind of practice this. So here we are at the problem, and the problem says, how many elements are in set B and C, but not set A? So how do we write that out? Well, if we write that out, B and C is written that way, but they're not in set A. So they're in set B and C, but not A, so that means it's a union A complement. So it's not an A complement. Alright? So given that, alright, this is what we're looking for on our diagram, and we want to be able to do that. Now, B intersects C, we can see, is this region right here that contains 7 and 3, and then we union that with A complement. Outside of A complement will be 6, 3, 10, and 8. And so therefore we can write that this is equal to the set 7, 3, and then 6, 10, and 8. And therefore, now we can answer the question. What we wanted to find was, in reality, the number of elements in B intersects C union A prime. And that's going to equal, based on what we found, the number 5. So our goal for these problems is to find the cardinality of the set. In that process, we're going to be finding the sets like we have done before. As a part of this process, we also want to write correct statements for the words. So let me give you one more problem here on the bottom. And the problem on the bottom, this is kind of a nice one. It says, considering sets A, B, and C, how many elements are in exactly 2 sets? So now we can go to the diagram, and if we look at the diagram, I can show this pretty easy. If I look here, there's a situation where I have elements in exactly sets B and C. Here's where I have a situation of elements in exactly A and B. And here's the situation where I have elements in exactly A and C. So all I need to do is add up the elements in there, and that would be equal to 1 plus 2 plus 3 plus 7, which is equal to 13 elements. Okay? And that's essentially the process for being able to do some of the problems that you're being asked to do right here. Okay, let's pause the video, and then I'll assign you a few of these, and we're going to get ready for doing some survey problems. So for the final problem, what I'd like to do is I'd like to demonstrate for you a technique that we're going to use on the surveys. So the next video we do is going to be pretty much applications where you have to set up a survey problem and fill it in and then answer some questions. But what we need to do is learn how to set up that survey problem. So what you see is an example of a 3-set survey problem where you have the 8 regions listed as I have listed them. And so what you want to do in this problem is you want to use all the numbers listed up here, the numbers of elements in certain sets, and be able to break that down. And there is one secret to doing this. Well, probably 2 secrets, but secret number 1. Always start with the inside most set. That's where you start. And then number 2, you just got to remember to subtract. And I'll show you what I mean by that as you go on. So, what would be the inside most set here? Well, the universal set's the biggest set on the outside. So the inside most set is going to be this one right here, region 5. And that region is the number in A intersect B intersect C. That is region 5. So we put a 7 there. Now the next regions we look at are going to be the intersections of only 2 sets, A intersect B intersect C and B intersect C. And so the number in A intersect B, which is now represented by this set here, well, I already have 7 there, but A intersect B has 17, So what do I need? I need 10 more in that set. And now A intersect B has 17. And notice I did 17 minus 7 to get the 10. And that's why I say you have to remember to subtract as you work out. So let's go to B intersect C. Well, it has 8 elements. Well, I already know 7 of them right there. So all I need is one more. 7 plus 1 is 8. So that will be correct. And then A intersect C is 11. I know 7, so I'll need 4 right there. And as you can see, we've done all the overlapping sets. And so that takes us then to the whole set. So right now in set A, I have 4 plus 7 plus 10, which is 21. And they tell me set A has 26. So 26 minus 21 gives 5. I have set B, which has 21, but what I already have there is 10 plus 7 plus 1, or 18. So 21 minus 18 is 3. And we can continue to find set C. And then now we can do the universal set, which says 38 total. But I have 5 plus 10 plus 3, 18. 19 and 11 is 36. So the universal has 38 total. So 38 minus 36 is 2. And now we have a set that illustrates the given information up here. And this set diagram can then help us solve problems like we did early. For instance, how many elements are in A and C but not in set B? So 4 and 7 are in A and C but not B, so you subtract the 7 and your answer would be 4. And that's the kind of thing that we need to do on this problem. Alright? So the last problem, in A and C but not in B. So you got 11 in A and C, but you got to throw out B, the 7. That's why the answer was to how many was 4. So that's the whole lesson in terms of dealing with sets and cardinality.